Thank you all for coming. Thank you all for having me and being here for this. Can I get everyone who, well, first, can everyone hear me okay? Is this, if I go like, does this work better? Or like this? Yes. Okay, so everyone who is capable, please stand up. I know some of you went to the bathroom and stuff, but just to make sure, everybody stand up. Thank you, awesome. And then take your hands and stick them over your head as high as you can. Yeah. Okay, and then you put your hands back down. Yeah, you can put your hands down. That's okay. All right, thanks. So, and people can still hear me, right? This hasn't changed. Okay, so you can sit down if you feel like it, or stand up if you want. So we're going to talk about core data performance. It's important not to sit for too long and stuff, you know. So this is what core data implementations look like in a lot of apps that I've seen. I'm sure some of you have had similar experiences. This is literally a rat's nest. I went to image search and looked for a rat's nest. So the problem is that a lot of people have either abandoned core data or are constantly complaining and suffering while using core data because their implementation has gotten super complex, super complicated, and it's probably not necessary. Most of that could probably be eliminated, and their apps would just work much better. Like a lot of people will tell you that it needs to be complicated for performance reasons, but here's the thing. We're not developing for this anymore. This is the 3GS, I believe. This phone had 20 megabytes of RAM or something we could use and a very slow CPU. This is not what we're aiming for anymore. Modern phones are much faster than that. Even, I think, what's the oldest that's supported on iOS 11? Like the iPhone 5. That is much faster than this thing was. So we don't need quite the extreme level of complications in order to support this stuff. Like there was a time where we were even looking at streaming JSON parsers because parsing all of your response from the server in JSON all at once would just take up too much memory and then your app would get killed. My friend made this app, Pinbook. Have you ever heard of the service Pinboard? Does anybody know what that is? Oh, yeah, I guess it's not very popular anymore. So there was a service Pinboard that lets you store bookmarks, and so that you could get them on your different devices or on the web and see them later. My friend made this app to let you get to them on your phone. The Pinboard API was not very smart and would just give you a list in XML of all your bookmarks all at once. And there was no way to limit that or say, just give me the recent ones, just everything all at once. So he made the app and found out that he had customers that had not just 1,000 bookmarks, but more like 100,000 bookmarks. So tiny old phone processing 100,000 bookmarks and trying to store them and display them did not work very well. He had to resort to basically every trick you've ever heard of and then some. He was using streaming XML parsing, and not just NSXML parser, but libxml. Like he was writing C code to handle it all. And optimization. It still took several seconds to download your list of bookmarks if you had 100,000 bookmarks. But even after he stopped supporting his app and other people made apps that were maybe more popular, I read articles that were still comparing the speed of these new apps to his, where his was much faster even though it was old and not supported anymore. But the reality is, though, that like most apps are not actually that complicated. Most apps don't actually need that much work. So I made this example app so we can talk about something specific. In this example app, we have an office and we have meeting rooms. And we need to be able to reserve the meeting room. So employees in the company have an app that can say, here's the meeting room and here's who reserved it, so you know which ones are reserved. Initially, the office only has the one meeting room because we're not that big. There's nothing special that needs to happen here. We can do everything in one context. We don't need to worry about multi-threading and backgrounding and anything special. We just get the data from the server and display it. It's fine. Anything more complicated for this would just be extra work done doing nothing and making things harder than it needs to be. We have instruments, which is one of the best performance monitoring tools I've ever seen, and one of the things that makes it, for me, super fun to develop on iOS. We don't have to speculate about why a thing is slow. We don't have to speculate about what's going to use too much memory. We don't have to play academic games about trying to optimize algorithms. We can just look at instruments and say, tell me the truth. What's actually slow? And I can run this on a device, and I can see where the time is spent in my code. I can see how much RAM it's using. We don't need to guess. And so we also don't need to optimize for things that aren't actually happening. We can just build something and find out where it's actually slow and optimize that. So in my example app, this is what happens when you download that list of rooms for the first time. We spend almost no time, 43 milliseconds on the main thread. And that's just doing all of the work on the main thread. HTTP work happens in a background thread because that's the way NSURL session works. But all of our, excuse me, all of our core data stuff is just happening in the main thread. And 43 seconds spent on the main thread to update everything. That's probably fine. Not a really big deal. We can go on to something else more important. When we reload that, though, it takes less time. So this is if we download that same list again, and we're using unique constraints to make sure we don't have duplicate rooms. It's still not enough to really worry about it. So our office grows. We get more employees. We have to go get bigger space. We need more meeting rooms because we love having meetings. And eventually we say, OK, well, what if we have like 1,000 rooms? Now we're starting to spend a little bit more time on that first load, 96 milliseconds. Like maybe that's enough to worry about it. When we refresh, though, it starts to become more noticeable. This is 2.3 seconds that the main thread is tied up almost completely doing that work. That's more of an issue and not something we would actually like to see. If you go to 5,000 rooms, then we get to some more obvious problems. 14.5 seconds almost is enough that you're getting close to the app just being terminated because you're taking too long. That's 14.5 seconds your user is sitting there tapping on the screen and nothing is happening. This is clearly something we need to do some work for. So the easiest first step, I guess, would just be to do that core data processing in the background. And so we use a background context for it. So now you can see there's still quite a bit of work being done, but most of that work, can I use this? Does this work? If I go, yeah. So you can see there's still quite a bit of work being done in total, but a lot of that work is happening on a background thread, and then a little bit is happening on the main thread right there. So now we're back down to about half a second on the main thread, which is much better. So that's a little hiccup while you're scrolling instead of freezing for 14.5 seconds. If you drill down into the actual data that Instruments is showing you, you can see that most of the time is spent merging changes from that save notification. So all that work we did in the background needs to be merged with the foreground context, and that's what's taking up most of that half a second that we were spending down there. Because in this fictional case, we're downloading a list of 5,000 rooms that we already had a record for, so every one of those objects is getting updated, which means every one of them needs to be refreshed in that new context. So now we start to do some things to hopefully make this a little more pleasant. This is if we tried saving our changes every 100 items instead of saving all 5,000 items at once. Now we get down to, well, so here we're using 1 second on the main thread, but you can see how it's sort of spaced out in here. So we're not freezing it up entirely. We're giving some space in between. This is a chance for the main thread to do things like animation. Still, most of this time is being spent merging changes, but at least now we have batches of smaller changes that can be handled faster and give the system time to do something in between. This microphone is like right in your peripheral vision. It's very strange. Yes. So here's one that I tried that actually did not work very well. I figure if you know that you're downloading a list of 5,000 rooms and you know you already have those records and you're just going to be updating everything, then why not let's just delete them all up front. We can do a batch delete in one step, and we'll delete all the items, and then we'll process all the new items. And then maybe that works better. Turns out it does not work better. So on the left is if we don't do that, and on the right is when we do. So here you can see basically what happens is because we deleted everything and then added everything, there's just even more changes to process. So this is the whole work that's being done. And then down here is where it's just happening in the main thread. So even though technically our core data work is being done in the background, most of it is still happening, well, is merging those changes. And we just made a lot more changes by trying to delete everything first. So this is a more realistic case. An API that gives you 5,000 items every time you ask for it is not super nice. In the case of that old app, Pinbook, the guy who developed Pinboard just didn't want to spend much time on it. It was sort of a side project for him. It was earning some money. And so he said, I'm not going to do anything. Here's the API. Good luck. If in your companies, hopefully the people developing your APIs care a little bit more. And then we can say things like, just give me the 100 rooms that actually changed and not all 5,000 of them. And then we can get down to using tiny enough amounts of the main thread's time that nobody cares anymore. So without any special code changes here, except for we're backgrounding the core data work, and we talk to our API developers about how to not have 5,000 items all at once. Now we're using 25 milliseconds worth of main thread time to process and merge those changes, and now our app is back to behaving smoothly. Sometimes the best optimizations are not necessarily in your app. How many of you work at companies where like the app and the API are being developed in the same company? Yeah, so most of you. And how many of you are on good terms with these people that develop the API? How many of you are at war with these people? Yeah, so buy them some cookies, sell them nice things, and say, hey, let's try to work this out so that the app isn't doing too much work. Because with this, in my arbitrary example, I just stopped processing after the first 100. But in the real example, when you're actually only getting 100 from the server, you're also saving on the amount of data that's being transferred, and you're saving on the actual processing time. So that's a little bit nicer on your user's battery. That's certainly nicer on the experience of scrolling and not having it freeze for 14.5 seconds. And using less data is generally good, because do you have unlimited data here in Italy? Is that an easy thing to get, or is it super expensive? Yeah. Oh, it's unlimited? Yeah. Yeah. So I'm in the Netherlands, and we do not get unlimited unless you pay ridiculous amounts of money, I think. So generally, using less data is probably a good idea. So for more information about these things, Apple puts out a lot of information about core data every year, and they update quite a bit of it. Some of it doesn't get updated, but most of it does. At WWDC every year, they have these talks where they introduce what new things they've added. They've added quite a bit in the last 5-10 years. Most people I talk to that are complaining about core data in their projects have never actually looked at the documentation for core data, and they aren't aware of these videos. They aren't aware that things have changed. There are newer things they could be using. They aren't aware of how it actually works. They're just aware of how they thought it worked and how they made it work. So in general, if you're going to use a framework, go find out how it was designed to be used and then use it that way. And Apple puts a lot of time and effort into making these presentations to show you what's new, what's added, how we can do things nicer. If you go back, I think the year before these even, there are some specifically talking about performance in core data and how to do things in ways that are faster. Like that, like why would you not take advantage of all this free information provided by the people who make the framework? And then also instruments itself. How many of you have used instruments? How many of you think it's the best thing ever? Yeah? Right? So, yeah, I've been to companies where they weren't even aware that instruments existed. They'd been working on their project for years, and no one knew the word instruments. No one knew that profiling was a thing you could do. It's a really powerful tool, and there is detailed information about it. They update it because instruments itself visually changes a lot. It seems like every other time I open it, it's different. But they update the guides to show you how to use it. They have video. This last link here is video. This will be available somewhere so you can see the actual link. This information is all given to you for free so you can take advantage of it and profile your code. Because not only can you see where core data is slow, you can see where everything else is slow. Yeah, so that's me, and this is how to find me. And if you have any questions or something, or I guess we can go get lunch now.